Hey everybody, it's Open Dave. Today on the show we're going to create this model right here. This model is a combination of these two models. One is a voltmeter, AC voltmeter. The other one is an AC amp meter. This is for a project that I will be designing on the channel. That is going to be a variable AC supply for the workbench for powering up equipment and stuff like that. It'll be based off of the same type of design that other people have on YouTube that has the incandescent bulb in line with the hot side of the power. To act as a load, a fuse. I'm not really exactly sure what they're doing with it, but we're going to build it. I have all the parts for it, or most of the parts, and this is the first step. We will be using this as part of the variable AC power supply that we use on our workbench. This model has two configurations. It has the amp meter and has the voltmeter. So in this episode we will learn how to make this particular item. Thank you. Hi everybody, it's Open Dave. We're just going to do a quick test here. See if I can switch cameras live. No, I cannot. Okay. So how would I go about doing that? That's a good question for Camtasia. I will have to submit, I guess, to their tech support. So we won't be able to switch over for us to look at these as I'm doing measurements. You just have to, I'll be using my calipers. I have a 12-inch set of Mitoyo. I'm not really sure how you say the name. I don't want to butcher it as bad as I just did. I need to stop saying that. So, what we're going to do is we're going to be using SolidWorks, and we're going to model up these two meters, the AC voltmeter and the AC amp meter. They have the same bolt pattern and size. The only difference being is that the amp meter is not as deep as the other, and the studs are in the same place. Not the same size stud, but the studs are in the same location. So other than those two things, we can create one model and call it one version and call the other one the other version. And we can set that up in the model to be two different part numbers with the two different lengths, with the different studs, and use a single part in a multi-configuration. So when we do our bill of materials, we have that. If you can't find these particular meters, at least by watching the video, you'll have the skills to recreate the meter itself or whatever it is that you're going to do. This is for the entry-level guys and gals that have not had formal class in SolidWorks, and this is my online connected SolidWorks, and we will go ahead and open SolidWorks. That should launch the locally installed software. Let's see here. I've never used that. There it goes. So, and you see we're running 2023. So I can go ahead and minimize this window. We don't need that anymore. And we will wait for it to start. While we're waiting, we can go ahead and just start getting some basic measurements. I will do this all in millimeters because it's all been done in millimeters. This stuff has all come from China, and everywhere except the United States, for some ungodly whatever reason, we're still on the inch system. Though I know it better than the millimeter system. If this video was to reach anybody outside of the United States, at least it gives them something that they're used to working with. I can work with both. I've done some military work where the documents had to be in dual dimensions. So just thinking along those lines kind of just stays with me. So we got the face. The circular face is 45 millimeters across, and the mounting is where we're going to start at, because we're going to use this surface, this back surface, as our, let's actually talk about this. This meter can obviously be installed one of two ways. From the back side coming forward, or from the outside coming back. And you can use both the front or the back as a mounting surface. So if you like the square part of the meter out in your designs, well, then install it to the outside. Or vice versa. I think when I do this, I kind of like just the little round part of the meter sticking through, and then we'll have some screws on the front side that will be holding this in. So, but still, my mounting surface that I'm going to start with in the design will be this back surface right here. So let me get that measurement itself. And we see that it is square, so I only do one measurement. And we got 47.15. So let's start our part. That's where we're at. Yeah. Hold on just a second, Monique. All right. Sorry for the interruption. That was my sister-in-law. She lives with Carmen and myself. We live in Texas. We've been taking care of Monique for a number of years now, since her mother passed away, or their mother passed away. And she is developmentally challenged. She's a very nice person, but there come challenges with age and what her mental age is, but that's not about this. So we're back to this. Okay. We have our diameter, but I actually forgot to reset this. So we're going to set this to millimeters, grams, and second, and it will take us out of the drawing, in the active part of the drawing. We're still in the drawing, but we're not actively drawing. So now you can see that this here gives us a millimeter diameter. So we had said this was 47.15. Oh, no, it wasn't. Oh, I'm messing up over here, but that's okay. We can take this and we can just use this as part of our template. We will leave that in there and just get out of this particular drawing. We'll come back to the same surface and we'll pick the rectangle or square tool with center on that. There, now we go. So let's grab these edges. And there are two ways to do this. You can, 47.15, you can grab the two lines and pull the dimension up, or I could just grab this line and pull the dimension out. And I don't like this particular version of doing this. And this goes back to the guy who taught me SolidWorks back in early 2000. Because I had been doing it this way. And he had pointed out that by doing it this particular way, that if I come up here and do this, you see it's going to delete that. Oh, I picked the wrong one. I'm being goofy over here. I picked this one and I hit delete. You see this dimension stayed on here. But if I was to have picked this line and hit delete, it tells me that I'm going to delete this dimension with that. Is that what I want to do or not? And you may have that intention and you may not have that intention. It's one of those things that as you become a modeler and you start looking at how you build your model so that it supports you in the long term of the model itself. Embedding features inside of other features is not really a good idea. But there again, sometimes it may be a good idea. Like I said, you got to take everything on a case-by-case basis, and you have to think about these things. Now, this has a minor radius on all four corners, so we're going to add that in. Okay. So we'll pick our radius tool here, and obviously 10 millimeters is too much. So we'll start off at 1 millimeter and see how this, if it matches what we have in our physical reality here. Actually, that's probably way too small. So it may be a 1.5 or 2 millimeter. So while I'm still in the edit mode of this, I can change this to 2. And it can give you the idea of, hey, that kind of looks like what I'm looking to get. Or maybe it's 2.5. Oops. Let me delete that and go there. And we'll just call that good. All right. So there we have that. Now we get our thickness of this. And it is 4 millimeters thick. So we'll get out of the sketch tool. And we'll go to our features and we'll do an extrude. Now for me, when I'm looking at this, I'm always looking at how I am in the screen. And you see from the corner triad in the bottom corner down here of the screen, the Z-axis is coming into your face or through the screen. So, and that's the way I always design my components. So we will continue to do so in that fashion. So there, that takes care of that. Now let's come in here. We'll go native to that face, and we're going to add in our 4 mounting holes that are in the corners. So we're going to grab a quick measurement off of that. These are measuring at 4.75 at the holes. Here's a little trick for you. You want to find the center of one hole to another hole. And you've got a set of calipers and it's in a linear line. That measurement you're going to get. You're going to get your calipers in, measure that hole, while applying just a small amount of pressure, hit the 0 button, which will then 0 your calipers. Then when you go and measure from hole to hole, it gives us 37 millimeters centers on our holes. And I didn't have to do any math. I let the caliper do the math for me. So nice little tip and trick there for you. And we will continue to work from there. So we had, come on, let's get up on the screen here. Go into sketch mode. We got the face highlighted. So we're going to go ahead and draw us another square. And we're just going to drop it here. We don't need to go out and get caught up on that line. As a matter of fact, why don't we take it and just turn that off for right now. But we're going to come in here and we're going to grab all of this. And we're going to turn this all solid. Well, let's try this again. I guess it's not going to do it for us. It's a nice feature that has been added now, or subtracted if you look at it that way. All right, go there. All right, remember we said this was at 37 millimeters. So we will do 37 millimeters. And 37 millimeters. Now we will take our holes, our circles that we're going to put in for our holes, seeing that we're not drilling this. This is just a model that we're going to be utilizing in a design. Now, granted, if you were going to be using somebody's meter in a professional design, you will get the 3D model, or you will try to get the 3D model from the manufacturer, and then base the design of your whatever it is that you're designing off of that model. And you saw that I linked all of these together so that they're tied to one dimension. I edit in one place and it propagates to all. So now we'll take it and cut that all the way through. And here again, this is another one of these things that you need to plan for. If your design is in a flux, you're still working things out. Your material may or may not thicken. If you know that it will never thicken, then use the thickness of the prior extrude the prior extrude that created that feature for your thickness, or it's just tied to it. But if you don't know, you'll want to go and just set it to through all. That way, if this thickness here, if this ever changes, I'm already assured that this hole will always go all the way through it. If I decide to come back and say, this part right here really needs to go up to 8 millimeters thick and go from there. And that's the only thing I'm focused on, is changing this thickness. I've taken the worry of me forgetting to come back and adjust this hole to the full thickness if it was to, like I said, go to a thicker product, whatever that may be. So there again, it's how are you building your models? What will they be used for? And is there a possibility that this model could be used in multiple locations? That, excuse me, that you guys have variants on the same part. The same tube that is used to make a tie rod or something. But you can get it in fixed lengths for whatever. Like I said, could be for an off-road vehicle that's used in the steering linkage. But you have different models that use the same material, same diameter. The only thing on it is different is its length. You can build that into the model if you had a feature that needs to grow or shrink with that. So that's the only thing I'm talking about with that. So back to this. All right, so we changed this back to 4 millimeters and call that good. Now we're going to go, let's turn this back on for a moment because we're going to use it. All right, I'm going to be drawing on this face, and I need to, like I said, go to the sketch mode, and we're going to convert entities, and we're going to grab that entity and actually say convert. All right. Well, what do we do wrong here? Let's go back to this. Let's exit sketch. I don't know what mode we seem to have gotten into. Go back to here. Sketch. Alright, we want to highlight this and convert that. Okay, okay, here's something different that is from the 2018 version, or I haven't used 2022 yet, so that's interesting. I want to sketch on here with a line. Okay, we'll just call that good for right now. Now we grab our sketch. We're probably going to be editing on this. Convert entity. There we go. I just must have got out of sequence with it or something. All right. So now you see that because that circle that I had there, I'm able to put this on here, and then we're going to go ahead and extrude it. And I only had to do that measurement once. And here's another little tip for you guys. A lot of people don't know this, but you have the tail pin here, and you also have the other set of the other side of the calipers for measuring inside. This is for measuring outside. This is for measuring depth. And what was I going to say about this? Oh, and also to measure height, you could use this also. But this right here is not going to get you very solid, on this. So what you can do is you have the back side of your calipers. You can come in and put that on. And now you've got this really huge, solid face that you can measure from by using the back side of your caliper. Another little tip, okay? So hopefully people are getting something useful out of this. And this shows that we're 8.32 millimeters. We'll just do 8.35. 8.35. And call that excellent there. All right, so we have, looking at it, we are looking very close to what it's supposed to be. So, something seems off a little bit on here. 47.15, 45. Oh, did I put the wrong measurement on that? I bet I did. Let's go in here and edit that. Yeah, I did. It's supposed to be 45. Actually, let's just do 45.5. Oh, no, not that big. 0.5. There we go. That's better. Okay. So let's take this and let's just hide this again because we don't need to see the dash line anymore. Now that looks better. Okay. All right, on the face of this, I mean, we could stop here and just move on. But if you're going to be doing in your CAD drawings, if you're going to want your meter to look like what it is representative of, me personally, I will add in the face of this and the cutout area, and then I'll probably just put a what it is, 0 to 300 volts AC in some text on the front on that, just so that just by looking at it, you can kind of get an idea of what it is. If you're interested in modeling it, I mean, you could go all the way down to the face. You could bring in a picture of it and stick it inside the meter itself to where it looks like the meter, so that if you were to do realistic photo shots of your products, it will look like this. I mean, so if this is your product, then by all means do everything you got to do, because you'll have to, I mean, you'll be modeling up every single part on here. I mean, we've got a couple of Phillips screws here on the back, so we know that this back part will pull out. We have this plastic, the 0 screw in the front. And then, of course, there's the meter movement itself, the face that is graduated for whatever measurement you're taking. I mean, like I said, go as far as you need to go. It's your model. In the professional world, where I'm going is where I will stop, and besides, the information is not coming from this particular model if you're using it in an assembly. But if this is your model for your product, I mean, because this is your product, and you create you're going to be creating all the drawings for all the obviously all the components that go into it. So, like I said, be as detailed as you need to be. So when you create your assemblies, it will be representative of what it is that you're doing. Okay, so back to this. We're going to be working on this particular face. We'll get normal to it. All right, we have a lip that is 2.8 millimeters from the outside edge. Now here you can't do that trick that I was talking about. So you literally do have to use the depth gauge in this and then go from there. And it's 3.05 millimeters out. Again, this was 2.8 millimeters. So what we will do here, we're going to sketch on that face. We're going to come in. We're going to put ourselves a circle. All right, we're going to exit that. We'll come in here and do this. And we'll get us 2.8. Now, we also have the flat bottom here of the meter movement, or the injection molded plastic, where you have your 0 screw at. So we're going to take a measurement from the outside edge to that inside edge. And we got 10.85 millimeters. So let's draw us a line from here to here. And now let's just do this. We're going to put a point there. We're going to put us a point right there. And we're going to come back. We're going to get us a line. And we're going to, well, we got kind of off on that. Let's start over and zoom in some. Oops, wrong way. All right, so back to our center line. All right, we got to do a couple of things. We're going to make sure this is, we grabbed the wrong line. Get back here, grab this guy. We're going to make sure this is vertical. So that way we know that any measurements that we add, they're going to be correct. And then we will grab this line. And here I could have done this again two different ways. So we'll do 10.85 and we'll adjust that down. Now I did this one way, so let's take it and delete that. Now let's do it the second way. I put a center point on here, and I also put a point tangent here, and I can grab the measurement that way. So now if I decide that I really don't want this line here, okay, I don't have the line here. And now I don't, you'll notice that this went blue, went from black to blue. So let's go back and look at that. There. This showed that this was fully defined in this way it was done. Here it says it's underdefined. The only reason it's underdefined is because we have these 2 points sticking out here at the end. Okay? And we're going to clip those off right now. So we'll come back here and say, yes, we're going to cut that. Yes, we do. And yes, we do. Okay. So what happened here now is that it doesn't think that it's still centered on this, on here. You see, it doesn't show the center on that. So if we come back and click this, because we do want it midpoint, now we're back to that. Now, what we also don't need is, because we don't need this line here, so we can, there again, we can do this two different ways. We do a cut extrude, and we just want this side to go down, and we don't want to go through all, it'll be blind. And again, it was 3.05 millimeters down. So there is that part of the meter, the face of that. Now, like I said, if you wanted to put the movement in it, you could put the movement in it. But like I said, for me, I don't really need that. Like I said, in the bill of materials, in the metadata of this particular part is where all the information that you're going to need to, like I said, do whatever it is you needed to do with this. Hold on, my son's calling me, so give me a second here. All right, sorry about that. My son called. He's got a dead battery on his vehicle, one of them, and he wanted to make sure that that's what he was looking at. Here again, back to this particular part again. We know that there's going to be a draft angle on this. I'm not a plastics guy, but if you know anything about plastics, there'll be a slight draft angle on this so that the mold and the part can, and the part itself can come apart. So we won't be worrying about that. But if you were modeling that, you would. For me, there again, I don't need it, so I'm not worried about it. Now, what I'm doing here is I'm going to put text that is centered on this dashed line. That's the line I'm using. So in this particular version, and actually, you know, we're not going to do that here, but we will get back to it. We will actually edit this part out. Let's go here. Let's take this and cut that out. All right, let's get back to, do we want to add, yeah, let's talk about that. All right, now we're going to add the little screw feature here. It is not going to be functional in this because it's going to be part of the feature itself. It's not going to be a separate part of an assembly. We know it's going to be centered, so we'll use the automatic centering on that. Let's get my glasses back on so I can actually see. There we go. And we'll call this we'll call it 7 millimeters. All right, let's go. Oops, wrong place. Seven. All right, and we are not going to care if it's not perfectly centered on this particular face. I am not going to worry about that. If we were building the assembly, then I would link this hole to whatever is behind this that needs to be centered. So what part of the zeroing mechanism that needs to be behind this screw feature, that's what I would center this hole off of. If you were buying the movement from another company, they would probably give you, however it is that you're going to create a mounting surface on the inside of this plastic component here for however it is you're going to build that, you would base it off of that information and dynamically set that hole up. But we are not going to do that. So we're going to do what we did before with that other. I mean, actually, I could have probably just turned the sketch on and called that good. But we'll just do this. And we'll center on that. And you see that locked us in. Now we will come up and we will extrude this. And we only need to come up about, let's take a look at, well, can we even get a measurement off of this? Because I don't even know how high it goes. It is this gives me about 0.15 millimeters. So let's do 0.15 millimeters. Okay. And hit OK. Now, we also know that there is a indent for you to put a common or a flat blade screwdriver. So we will also mirror that just to give it some kind of look. Here again, in the professional world, I would, if this is not part of what it is that I'm selling, it doesn't exist for me. The main features is all I'm concerned about. The injection molding tooling holes, material reduction holes, whatever it is that I don't care about, because it's not going to alter how this part is used in my design. Okay, so this right here is just an aesthetics thing. So I will do so. So we will get on this face. We'll get normal to it again. We'll come up. We will grab this. We will touch our edge, turn the center feature on, and come in and do that. Now what I should have done, let's do this also. That way you can actually see it being done. Let's go back. Actually, we would want this particular one. So here it is. We turn this on, come out, do this. Well, that's not working for me. Looks like we may be editing this part out also. Let's come up, come back. Oh well, it doesn't matter. I'm just being stupid here, I guess. Alright, this thing is 4.7 millimeters. Now also, one thing oops, wrong way. Here, we're going to do it that way because we know we're not ever going to change this feature. What are we doing? We got a width here of 1 millimeter. Now we will cut this. And we will we'll just go the distance that we went just because I don't have to worry about it. Now, what we are going to do is we are going to round this down to where this edge is just slightly above this face, come across up to the center of this particular part, and then with a real gradual curved line coming down to the edge. So what we need to do is we need to get the center of this circle. Well, we can go a couple of ways. We can go back and look at where did, when we made this feature, we also had a sketch, and you see that sketch is 10.85. So we can come up here, seeing that we didn't draft this, we kept it as a perpendicular face. We're going to insert some reference geometry, a plane. It's going to be based off of this particular face, and we're going to do 10.85 divided by 2 gives us that. Now we're going to flip it into that direction right there. And oh, I know what I did wrong. I still have this 2.8 millimeters of offset that I didn't have. So we go plus 1.4, and there we go. That gives us our center on that. I'm sure somebody may come up and have a faster way to do that. If I would have drawn this line, I mean this feature right here in the right angled direction, or lying across this, I could have used it to create the face. I can show you. This will give us a reference, but it doesn't do anything. We know that it's 1 millimeter wide, but let's say you have something that you just don't know what the distance is, and you may have other features in the way. If you just come in and do an insert reference geometry plane, it automatically knows you want the center because you picked those two particular faces. So it automatically calculates for you. No math involved. There it is. It's thrown in the center of it. And now again, actually I could have done it also with these two faces now that I think about it. Here it is. I was being difficult with myself when I really didn't have to be. So remember, you can use past geometry to, just to click on, just so you can highlight things and get measurements from also. Don't forget you can tie measurements to other measurements, and we'll probably look at that also here soon, but not right this second. So we'll get that particular face, we'll go normal to. Seeing that it knows that we're normal to that, and that's not really the direction I wish to go, so let's just grab this. Okay, we're going to draw on this particular surface, on that reference geometry that we created. So it flipped it back over on me. It's no big deal. So I want to grab this. Come on. Get in here. There we go. All right, so you see this is coming out as a straight line. If you come back and then come back, you see it's got a curve to it now. And we're going to come up here and tie this just right here above it. It doesn't really matter where. I'm just doing this so I can see a good line with it. So I'm going to leave just a small distance here. Now you saw what I did here also. You saw that I picked this face versus this point. Okay, here is design intent again. I know this will always be referenced off of this particular face. Okay, I may want to come back and let's say after your prototype, you need to increase the height a little bit or whatever it is, and we'll just say it's this for whatever reason. Now, remember what I said before when coming in here to delete something. If I would have tied my measurement to this line segment, when I cut this out, guess what? That point just disappeared. My dimension would have disappeared with it. So, there again, design intent. What were you trying to do? How did you need to get there? Okay. So, we've got this. Now, we need to come up here and say View. We want to turn on temporary axes. Okay, we have that. Let's get out of this mode because this is going to be our revolve line, our cut revolve line. Now, if there would have been some odd features or anything like that, or it could come back that these two lines may come up and not be touching this, or touching or overlapping each other somewhere down in this here where it doesn't work. And here where I've had to do that, you would take this line, turn it into just a construction line, come back, extend this out, come back, we're going to use the assist, and now we have that. So if there's any kind of way that this cut revolve would have been a problem for us, then we could have taken care of that. So now let's go into our features, do a cut revolve. Yes, we are doing all of that. No, this line is not the line we are working around. This is the line that we are working around. Now you can see that we are going to edit that face. We're doing a blind and it's 360 degrees and we hit OK, and there we are done. I know this took a lot longer than it should be, but this is also, like I said, this is learning. I want to instruct people on on some good practices, at least that have helped me out through my career, and we'd go from there. All right, we also know that there'll be some tiny radiuses here, here, here. We could put one on here also. These particular ones, and here again, you can take, if you know your one radii that's going to be used on multiple faces, you can grab them, or edges I mean, you can grab them up front and click the tool, and see, and it comes up with 10 millimeter. It's obviously way too big. What is it not liking? Oh, it did it, but that's way too much. I should have known that right off before I even executed the 0.25. There we go. Let's do that. There we go. Now we have that. Now also, while you're working, if you've got lots of planes on, you can hide them. Remember, we still have this axis on. We also, if we look, there's another axis right here in the center of this. All of these, anywhere there's a radius or circle, there will be an axis point where that was fabricated from. So we don't need them on at the moment, so we can go back and go to temporary axes and axes. We don't need any of them on. Okay, so we're done with the face. Now let's come up here and do the back side. We're going to do the body of this. All right, we already know that it is the same thickness as the front side, which was the 45.05 that we gave us. So, but we also have this tool here again. So we're going to draw on this face. Oops, sketch. I'm being dumb here again. There we go. And like I said, get on this and click on you and click you. No, it's still, I don't know what it is about that I don't like. What is the deal, man? I don't know. Oh, it did something else. It did what I did not wanted it to do. Yeah, let's discard that. Yeah, you see it turned on. It put a sketch to the outside edge, and that's why it won't follow through. Okay, well, that makes sense. Go back here. We're going to sketch on that face. We're not actually going to sketch, but we are going to, let's turn this back on so we can actually grab that. There, it did it again. I am not digging that. Yes. Discard. Yes. We're going to sketch. We're going to grab that. Grab that. There we go. Jeez, man, that was a pain. All right, our depth on this is, using the backside of our caliper, we have got 30.55. So let's extrude that at 30 point. We'll just call it 6. We're not designing a spacecraft. I'm not designing a car. I'm designing a model that's going to go into a piece of test equipment that I am going to build for my workbench in the other room. So now we've got we've got this done. Let's turn this back off because we don't need that. Oh, what are we doing? Let's get on here. All right. Now we've got the 2 screws to add to the back. All right. They are 3.8 millimeters in diameter. Actually, about 3.85 with a little bit of a loose grip. And this also works in reverse. So $15.3 is what I've got the centers, and 3.85. All right, so let's go. Draw a circle, draw a circle, and we've got equal. Let's come in, grab the piece of construction geometry and chain. We're going to grab the center line, go to the center here, turn this vertical. We've already got this at the midpoint, so now we know that whatever it is we do, they will be where they need to be. All right, so if we come here and do 3.85, get our fat fingers here going, and we do 15.3. What was that? I can't remember now. Yeah, 15.3, maybe 15.25. And the only reason I'm able to do that, the ends of the screws actually have a concave with a point in the middle. So I'm able to use my points on here to go center to center, and I'm just going to round the numbers. Here again, I'm not all that, doesn't need to be, because I'm not designing this part. If I was designing the part, then I would be obviously meticulous on that. Let's just say 2.5. And now from here to here, let's see. How am I going to get a good measurement for that? We'll call it 9. So how can I get this to 9? .85. I got 10.9 minus 3.85. If I go here, it gives me that number. We'll just call this 9. All right, let's, oops, I turned that off. There we go. Let's go up. Now you see, this is just going to grab the edge. And I could do this from here to here. But you see, the measurement comes up the opposite direction of what it is that I want. So we'll just go ahead and leave that there. But look at here. We go to liters. We can go to max. And it'll come up on there. And we can also go to min, which brings us up to the top where we were at. And we wanted this to be 9 millimeters. So we just change that to 9. And for some reason that just don't quite look right to me. Maybe I forgot to re-zero this thing. Let's come up here All right, we got this 3.85 divided by 2 is what? All right, I figured out my mistake here. My math went sideways. Oh, you do need math, okay? All right, so these are 15. I mean, a 3.85 in diameter, and I measured up to this top edge, but I had to measure from the outside of the screws up to this edge. Okay, and I got 15 point. We'll just call it 15.2. Plus, I have to subtract half of the diameter of this to get the correct location. So we got 15.2 minus 1.925 gives us there. That looks better. Now also, I did forget to re-zero this to get the absolute center on here when I still had the diameter of this zeroed on the caliper itself. So here it is. So we got 19 millimeters is between these two. So let's set that to 19. And now that looks a bit better. Okay. And what is the height of these guys? They are 8.8. So let's go ahead and make that 8.8. All right, this video is going to have to be, oh wow, I'm an hour into this already. Man, I sure hope I haven't talked y'all's ears off. All right, so we've got this, we'll call this done except for what we were going to do to the face. But we also talked about doing this as a configuration for 2. All right. So here's where this comes into play. All right, we will come in here and we'll do this. Our default configuration, let's go in and edit the properties. Default is going to be our AC voltmeter. AC voltmeter. And here we'll call this also, and we're going to also use this in the bill of materials. So we're going to call this meter panel. Oh, I did not. Panel mount. Dang it. All right, let's quit fat fingering. Here we go. Panel mount AC, and it is 0 to 300. Actually, let's change that. It's going to be redundant if we have that here twice. So let's do 0 to 300 VAC, and we'll add in the class on it also. Okay, this is class 2.5. All right, so let's go back and fix that. Okay. And now here, document name. We're not going to use the document name. We're going to use a user specific. And this right here for me is where I put the part number, the specific part number. So I'm going to put, this is a Bowman class, SO45. Both of these say SO45 on that. So I don't have, oh wait, here we go. Here's the box for the panel meter itself. And it states, so let's actually change it to include that. Let's put it right here. Let's put, oops, BAOMAN, Bowman class 2.5, and here let's put the part number. The part number is X001C5 U5JJ. Okay, and let's do that. Now let's come in here and say we're going to add a configuration. Now we're going to add in the AC amp meter. All right, this right here is, again, it's a meter, panel mount. All right, we'll just stop there just for the second, because here we should have been a little bit smart about this. So let's click back on this guy. Let's go to properties. Let's come in here and let's copy all this. We should have copied it when we were editing before, but oh well, you know, I mean, hey, this is a live build. So let's go here. Put this in. Now this is it doesn't say Bowman on it. Oh yeah, it does. This is a Bowman amp meter. So it must be the style that it is. So let's capitalize off of what it is that we got. 0 to 10 amps. This is an AC meter, and this is and here it says SO45 on that, and our gauge size was 45, so that must be the meter size as part of its description. I won't include that in there, but you know, that's just for deducing something as what it is you're working on. Here again, we will come down and we will make a user specific. And now let's put in its part number. This is X002ODIV4T. All right, so now, because there is no difference now between this meter and this meter, they are identically the same, okay, we can come in here and start altering things for this particular version, okay. So if we were to come back into here and we take a look at the body of this was a certain depth, this one is shallower. So let's go in and take a look here, get our measurement for that. This one here is 25.85. So we come into this and we edit this and we'll say 25.85. And you see that just changed that. Now, coming down looking at our screen, we see we have some specifications here. No, we don't want to do it. We just want to do it to this configuration. Or you can come in and say, let's say you have 15 different meters. And in each you got 4 different amp meters that are the same and 5 different voltmeters that are the same. But then you have 2 other voltmeters that are different. Well, you can pick which ones you want by doing that. So you can have, I don't know if you want to call it a multi-stage. Hold on a second.
Hey Dave.
All right, so back to this. So like I said, you can specify different configurations. Maybe you even have a voltmeter that's based off of this particular setup. But we're just going to say this one because we're not going to have more than this, because I'm not buying, at least I don't think I'm buying any more meters that are going to be like this. Not that I have anything against them. I haven't used them yet. But this is just what I have, so this is what I'm going to use. So now if we go back to here and we switch, you see the depth just changed. Now what I should have done also was I should have put the fillet on the back of this, and this right here we're going to say 1, no, how about 2.5 and call it, yeah, that's way too much. But see here now, and the reason I show you this also, if I go to here, you see that feature did not carry across because it wasn't part of the duplication that happened when I did the part configuration from one to the other. If it had already existed when I had made it, then it would have stayed there. So I would actually have to come in here now, add this, and we will do 1.5, and that's good. So now we'll come back to here. You'll see that this one is way too big, so we'll have to come back into the tree. And when we look at the tree, you'll see you've got a fillet here, but it's turned off. So this guy, we're going to edit this guy here, and that's where the features reside. They're still in the tree, which this is the tree if you didn't know, and go from there. So now another thing that I like to do in my models, my job consists of me designing 19-inch rack mount custom enclosures for test equipment that we build for customers. We support a lot of different industries. You can check out G Systems if you're interested. If you look at our home page, you'll see a lot of my designs that are in used as part of the equipment that we send out to our customers. So back to what I like to do. Seeing that I like to save time in designing something, especially if you're building a model. The reason that you're building a model is because you're going to use it in the design, obviously. But if you're working for a large company, you're going to reuse that model over and over and over and over and over in different designs itself. For instance, connectors. You may have a deal with a certain manufacturer that you'll use their I/O components only. It could be a DB connectors. It could be a SCSI connector. It could be a military circular connector. And these particular things always have the same mounting configuration. So to save yourself time, you need to come in and up front in the model build in components that will save you time. Okay? For me, I've got any hole that I have to carve into a piece of metal. The boxes that we design are laser cut, so we have a high degree of accuracy. The company we use has never let us down. If there has been an error in their fabrication, let's say a component was left off as part of manufacturing by accident somehow, where a PEM nut wasn't installed. Yes, I use PEM nuts in my designs where I can, especially if something is going to be a fire and forget. And when I say fire and forget, that is it's going to be installed and no one's ever going to touch it. There's no reason to take the labor that is going to be used for whoever's going to be building your product on your production floor to put a screw, appropriate washers for load distribution or for locking, and the appropriate nut that's going to hold all that together. You see, I've already called out between 3 and 4 parts, or 3 and 4 parts for each hole location. And sometimes that may be what you need, but not all the time. DIN rails, when they're installed, they're screwed down, and they're forgotten about. You never are taking one out unless somebody has damaged it somehow, or if you're taking it out because you need to, there's some tolerance, there's some room left in there that you can exploit for whatever it is that you're going to do. And if you can throw another, 10 millimeters, 5 millimeters of DIN rail, and that buys you something, well then, okay, you're going to touch it. But there again, you're going to touch it only once. You're going to put the hardware back on, mount it back down, and you're going to forget about it. You're not going to touch it anymore. Okay? So, if you're using mounting holes that are drilled, here is where you would come in and say, okay, I'm going to use I don't know what size this was. I didn't measure it. So this is a 4.75. So this will probably use 4 millimeter. Yeah, probably use 4 millimeter screws. So we'll do 4.75 as the hole. We can use a little bit of slop. Now here, when you're designing things, if you're going to have powder coating, and your manufacturer can tell you with certainty that when they powder coat something with whichever material you're using, the thickness is going to be, here it is, I'm going to go inches. Here, let me pull this up because I just, about between 0.07 and 0.1 millimeter thickness. Build that into your model. That way you have that accommodated if you don't care if overspray is inside of your hole. Yes, this hole could be masked off. For me, I build enough tolerance in. Nothing I'm building is flying into space or flying into, in a jet. Everything I do is ground-based equipment. For your airborne needs, automotive needs, you have tolerances that you will support for that particular design. For me and my bench, for me in mounting a panel meter that's going to sit in a 19-inch rack in a lab for years, me having a little extra room, because first off, I also don't know what the tolerances of the plastic is. Is this the first out of the mold, or is this the 10,000th out of the mold, or is this 100,000ths? 100,000s have been manufactured out of the mold. So there is going to be those tolerances that you just may not know about. So I will compensate for me, and I will go 0.35 millimeters on that. That gives me more than enough room, and I will hit OK. Now I will come on this side. I will draw on this particular face, and what I will do here is I will take this and I will convert those entities into that. Now, the only reason I show you this is because mounting on the face versus mounting on the back of a component. There could have been where the meter cutout was a lot larger than the movement needed to be on the backside. So you'd end up with two different size holes. So what I do is I build in to my model. Sorry, I got to move the camera here a little bit to get that right. There we go. Okay, you see that I did this and I'm done. Okay, and now if we look, you see that I have a sketch on both sides, on both faces. So this one right here, come in and let's double click on that. There we go. Boy, that was painful. And this is rear mount gauge. And here, again, let's come in here and do front. Okay. So as we can see, I need to build a recording light outside. Actually, I need to put it out in, my office is in the garage. I've took half my garage and I've turned it into my office. Then I have the other half. So we need to put a sign outside that's lit that says recording. Okay, we're back. There, hopefully nobody will be barging back in on us. We'll see. So where were we at? We were talking about mounting front and back, I think. So yeah, we were actually typing in here, front mount gauge. Now, then we will take these and we will hide these features so that when we come to use it, we'll just turn it on when we need it, turn it back off when we don't. So here it is. We have got our part done. So let's do a save. Save to this PC. And you'll see here that I had modeled these before, but I modeled them as two separate parts. I really don't know why I did it that way. Maybe because I just wanted to keep the same just two separate models. Maybe because they probably come from different companies. That would be the other thing also. And that doesn't mean you can mix if you're able to name the part in a way that would help you, but that to me would be a little difficult. For me, I wouldn't do that. I may copy the part into the manufacturer's location that you would have on your computer. And for me, we'll just put AC panel meters. And then here we just put panel meters. Because this description is not going to do anything for us in our bill of materials, because we built the part in the way that we needed it. Now, here let's also talk about information on the part itself. So if we were to come in here again, you would also set your colors. I'm sorry, we get a little off track here, or I'm getting a little scatterbrained, I guess, or something. But we come in here, and this is where we could set our colors for the panel meter itself. That's a little too dark for me, but it is black like that. We could just do that and say OK. And then in here, because we know these parts are they're metal, we could actually change this to something that looks more resemblance of metal. We come here, do this, and hit OK. And come here and hit this. Let's change this to, let's make it white. Not that it really shows up good on the screen here. It always shows up as gray, and that never enthused me about that. And I don't know if that's a monitor thing, video card thing. It just white just never looks right. And here again also we're back to the configurations of this. Here again, for a quick whatever, you could come in. We are editing the AC voltmeter, so we could come in here and say, let's draw on this face. Let's come in and do this. And we could just come in here, take this, center it on this. So we're back on here. Now we're going to come in here and we're going to put some text on here. We could come in. This right here shows that we have that line selected. Let's put text in. And we can say let's put caps on, AC, actually 0-300 VAC. Let's put this as centered. And now here we can do again a couple of things. We can extrude this, we can cut this, or do a cut extrude. For me, what I do is I take this and I will go to insert a curve, a split line on this face, and call it good. And then there we have text that is 0 height, 0 anything, and we can fix this. I guess we're being interrupted again. Let's pick the right color. And looks like we may have to take a break here and go do this. And hit OK. And there, now you see that you have this. And it tells you right up front, hey, this is, yeah, I don't have to go into the properties to see what it is, anything like that. You can put all kinds of text that will fit in here that will help you out. I do this a lot, as a matter of fact. And when it also comes to the part itself, come in here. Actually, I'm in the wrong place. I should be under Tools and Evaluate, and let's do Mass Properties. Because we don't know what the weight of this is from the manufacturer based off of the parts that are used to make it up, the glue, the whatever it is that's made in here to make this, you would put this on a scale, get a measurement, and say, listen, hey, we're going to override this because I don't know what the materials are. So we can come in here and say, hey, this is 100 grams. There. Now we know that if we were to do a weight calculation of this, we would at least have a good weight for the part. You would do that. Now, if this was built out of brass and you had the ability to pick the right brass, you should have a weight based off of the geometry that's left as part of your part. So, thanks. This is Opa Dave. Hope you come back. We're probably going to break this video up into multiple parts. It seems to be I took an hour and a half after I edited it. Maybe it'll be down to an hour 20. So who knows? We'll see. Thanks. If you like, give me a thumbs up. Subscribe if you feel like it. It would be nice to get some subscribers, and that's what all this is about. So we will continue on with the next part on our next video. Thanks, everybody.